Alright, in this problem we're trying to solve for x, and it's a log problem. One thing that makes it a little tricky as well is this negative exponent right here. So there's a few different ways you can do it, and if you do it different than me, then it doesn't mean you're wrong. I'm just going to do it the first way I thought of doing it. So first of all, let's talk about that negative exponent. Thinking back to Math 1010, a negative exponent, we can make it a positive exponent by switching the floor, is what I call it. If it's already in the denominator with its base, so this one is a base 10. If it's already in the denominator, if we bring it up to the numerator, that will make the exponent positive again. And if we had something that was already in the numerator and it had a negative exponent, we could bring it down to the denominator. That would make the exponent positive again. So what we're going to do is rewrite this as the log of 10 to the fourth times x equals 6.9. So all I've done so far is change the negative exponent to a positive exponent by bringing it to the numerator. Then what I'm going to do here is use one of the properties of logs that allows us to expand. When we have the log of two factors, a factor is something that's being multiplied by something else, we can expand it into the summation of individual logs. So I'll have the log of 10 to the fourth plus the log of x. And I decided to do this because I'm trying to solve for x, so I want to eventually get my x alone. So anything I can do to separate it from the things that are next to it will help. So from here I can recognize that something can be simplified. And if you look at it, can you tell anything that can be simplified here? It's going to be this log of 10 to the fourth. Well, what's the base of this log? I don't see a base. Right here, there's usually a base written, a little number. I don't see one. Doesn't mean that there's not one. It just means that it's implied. It's the most common base used, and so because it's used so much, sometimes you don't even see it there, but it's a base 10. And when you have a log base that's the same as the number you're taking the log of, they basically turn into the number 1. And it has to do with, if I come up here for a second and write it out, the log base 10 of 10 to the fourth equals question mark. It has to do with changing a log to an exponential. Remember that the base, the 10, raised to the other side of the equal sign, has to equal this middle stuff. So if I ask the question, 10 raised to what would give me 10 to the fourth, I would know that that would have to be a 4 right here. In order to make it true, let me erase, I guess that just erased the top one. Anyway, this has to be a 4, because then 10 to the fourth would equal 10 to the fourth. So this whole thing here is just a number 4. So it's simplified into that whole number. So I have the 4 plus the log of x equals 6.9. Since it's just a 4, I can subtract it away from both sides, leaving me with the log of x equals 2.9. And finally, again, I'm going to use the rule where this log has a base 10. So to change this, again, I'm trying to solve for x, get the x alone. To change this to exponential, I can say the base, the 10, raised to the 2.9 power, has got to equal x. That's one of the main properties of logs we use all the time, is to change to an exponential function. So 10 to the 2.9 equals x. And we finally got our x alone. So we have solved. So 10 to the 2.9 is our answer. If we wanted a better kind of decimal approximation of that to figure out exactly what that number would look like, we'd need to put it in our calculator, 10 raised to the 2.9 power, and we'd get an answer for that. So that is how we ended up solving this problem.